Welcome to doassignment-ca. Here is the problem. A train starts from rest at station A and accelerates at 0.5 meters per second squared for 60 seconds. Afterwards, it travels with a constant velocity for 15 minutes. It then decelerates at 1 meter per second squared until it is brought to rest at station B. Determine the distance between the stations. Now, let us work through the solution step by step. The train's journey has 3 phases. First, it accelerates uniformly from rest, then it cruises at constant speed, and finally it decelerates to a stop. We will find the distance covered in each phase and add them up. At the end of phase 1, the train has been accelerating from rest at 0.5 meters per second squared for 60 seconds. Multiplying gives a final speed of 30 meters per second, which becomes the cruising speed. For phase 1, we apply the standard constant acceleration distance formula, or equivalently integrate the velocity function from 0 to 60 seconds. Both give 900 meters. During the constant speed phase, the train moves at 30 meters per second for 900 seconds, covering 27,000 meters. In phase 3, the train decelerates at 1 meter per second squared from 30 meters per second to rest. Solving for the time gives 30 seconds. For phase 3, the distance formula gives 900 minus 450, which is 450 meters. We verify this using the velocity squared relation, and it checks out, adding the distances from all 3 phases. 900 plus 27,000 plus 450 equals 28,350 meters, or 28.35 kilometers. That is the total distance between the 2 stations. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.